Hello everyone, today we're going to learn section 4.2 limits and continuity. So limits, same as in calculus 1, we learned that, right? So we need to find the y value when x approaches to a. And continuity, let me talk to later. So it's the same concept as calculus 1, but slightly different because we are talking about 3 dimension here, right? Okay, so we have a learning objective. And as I told you earlier, in calculus 1, how did we find the limit of the function, right? So when x approaches to, when x approaches to a, then if a limit exists, there is L, just any number, right? Then random number. How do we find? We have to find, here is a picture. So x is y-axis. Then the limit, we have a negative, right? So it approaches from the left, right? Then there is number L, right? And then how about plus? So plus means approach to from the right, right? Okay, so there is also L. So since two numbers agree from the left, from the right, right? So we can say that the limit exists and then limit is L, the number, right? Okay. We know that, right? From the left, from the right. Okay, so for example, we have the function polynomial. We knew that from left to from right is the same value, right? So when x equal to 2, then how do you find? So f of 2 equal to 2 to the third power 17. It was a 17, right? So we apply to limit, so 2. So 2 to the third power plus 2 times 2 squared plus 1 equal to 17, right? Okay. In calculus 1, what was the continuity at A? So basically, limit, find the value of the function when x approaches A, right? So continuity, just think, we don't lift the pencil, right? No lift the pencil when we draw the graph, right? From the graph, how about that? Think, yeah, think. Okay, so calculus 1, continuity at A means the function must be defined. In other words, function cannot be undefined, right? So when denominator equal to 0, we say the function undefined, right? I told you earlier. No undefined, no undefined. We changed before. Hold on 1 second. I'm struggling. All right. Okay. That means f of a exists. Second one, the limit exists. Yeah. Okay. So function defined means f of a exists. And then the limit exists. Then we say that the value of the limit, and then we evaluate the function when x equal to a, they are same, right? Then we say that the function continuity at a, right? So it must be 3 conditions satisfied. Okay. Now, calculus 3, right? So let's talk about that limit first. So look, instead of x, right? So instead of limit when x approach to a, f of x, right? We have f of xy. Yeah, we talk about that last section. And then xy approach to AB. Can you see that? It's slightly different, but same concept, okay? So means that we do evaluating the function. So we evaluating function, find the z value, all right? Okay, now we have properties of the limit. This is exactly same as calculus 1. Only difference, they change that. Can you see that here? We have in calculus 3, only difference with this one. Yeah. So xy approach to AB. Yeah. Every property has constant role, right? So normally we have limit x approach to a, c constant equal to constant, right? But we have limit xy approach to ab, x approach to a, right? So everything is the same as the calculus 1. Can you see that? The sum law, we have that difference. And then constant, product, quotient, power, exactly the same. Yeah, make sense? Okay, so let's do this example, find the limit. So we want to find the limit when x, y approaches 2 and -1 respectively, and x squared minus 2xy plus 3y squared minus 4x plus 3y minus 6. Yeah, okay. Straightforward, right? So we can just apply 2 and -1. So 2 squared minus 2 times 2 times -1 plus 3 -1 squared minus 4 times 2 plus 3y -1 minus 6. Can you please calculate? You got the -6? Good job. Okay, second one, let's take a look. We have a fraction. Then the limit, we want to find the limit when x, y approaches to 2 and -1. Oh, same as, right? Okay, then we have to check the denominator, whether the denominator, the denominator equal to 0 or not, right? So if the denominator is 0, we have to do something other algebraic techniques, right? So, okay, let's calculate quickly. So 4 times 2 times -3 times -1, which is 11. So that's not the 0. Then we can just apply the limit. All right. Okay. So 2 times 2 plus 3 times -1 over 4 times 2 minus 3 times -1. So denominator has 11. And numerator has 1. Very good. Good job. Ooh, you cannot see. All right. Okay. So in 3 dimension, there is a question. Or it, ooh, Sorry about that. Okay, so when xy approach to 0, 0, or some other, the limit 2, right? Any number, right? So we have the function f of xy. Then how many paths approach to xy? 0, 0. You saw that answer already because I didn't want to write down. So I wrote down earlier, right? Okay. So there is infinitely many paths to approaches 0, 0. Okay. So look, we have x and y, right? 0, 0, 0, 0. That's it, right? But in 3 dimension. So I picked just a random equation function there. So 0, 0s, which color is better? This color? So we want to go to 0, 0. We want to go to 0, 0, 0, 0, 0, 0, 0, 0. How many paths, right? So infinitely, or from the bottom, right? From the up, right? So infinitely many paths approach to 0, 0. Make sense? Okay, so let's talk about this. All right, so in calculus 1, when you find the limit, if we have left, right, to get the different answer, not to get the different answer. If we have two different answer, then we say that the limit does not exist, right? So I have this one, 0 from the left, we get 1, 0 from the right, we get -1. Then we say the limit does not exist, DNE, right? Yeah. Okay, if the limit existed, we just did, it must be same number, right? Okay, now here is the same in calculus 3. Show that neither of the following limit exists. So does not exist, DNE, right? So we have example question here. So 2xy over 3x squared plus y squared. So let's take a look here. So we are using techniques here. So what kind of techniques? Fix as along the path y equal to 0. That means we substitute y equal to 0. Huh? What do you mean, right? So it's already xy approaches 0, right? Okay, so before we apply this limit, let's just fix that y equal to 0. Yeah, what this means? This means to substitute y equal to 0. Okay, so let me show you this. So limit, let me just copy. And then equal to, and then limit xy approach to 0, 0, and 2x fix y equal to 0. So 0 over and 3x squared plus 0, right? Okay, so numerator has the 0. Yeah. So we have a limit xy approach to 0, 0. We get 0, right? Then we have a properties constant equal to constant, right? So which is 0. Yeah. Okay. Now other techniques similar. I need a space now. So fix let's fix as along the path y equal to x. So let me just copy everything, change that. Okay, y equal to x, copy. So in that case, I don't want to make a path x equal to 0. If we make x equal to 0, it shows the answer also 0, right? So we don't want that because we want to show this problem as does not exist. Does not exist means we show that there is two different answers, okay? All right, so y equal to x. Then substitute y equal to x. Okay, now y equal to x, yeah? Copy, paste, y equal to x, right? Y equal to x. Y equal to x. Y equal to x. Y equal to x. Yeah. Okay. Then, oh, hold on 1 second. Let me see. Okay. Yeah. We have a y squared, right? So x squared, right? All right, then in that case, we have a limit x, y approach to 0, 0. We have a 2x squared over, denominator has 4x squared. Okay, simplify, we get limit x of xy approach to 0, 0 and 1/2. That's it, right? Okay, constant again. If we have a constant, then it's a constant itself, right? So we have 1/2. So look, we show that when y equal to 0, we get 0, right? If y equal to x, we get 1/2. So we can say that we can conclude the limit does not exist, right? Does not exist. All right. Okay, let's do this one. Second one. Limit x, y approach to 0, 0 for xy squared over x squared plus 3y to the fourth power. Okay, let's fix y equal to 0. Different color. Okay, so we have that. Equal to limit x, y approaches 0, 0 for x 0 over x squared plus 3, 0, right? Okay, so numerator 0 over x squared, right? Is 0, right? So limit x, y approaches 0, 0, 0, which is 0, right? Okay, how about this? Since we showed that earlier, y equal to x, let's do different way, right? Fix fix X equal to y squared. Okay, let's do it. So we have that. Oh, we have this. So that will be limit x y approach to 0, 0 for y squared. Y squared, y squared over y squared plus 3. Ooh. Oh, I'm missing squared, right? Look, y squared to the square, right? There's a squared. Squared 3 y to the fourth power. Yeah. Because we want to make a common denominator. That's why we set it up, x equal to y squared. Okay, now we can simplify. So xy equal to 0, 0 for y to the fourth power over 4y to the fourth power, right? We simplify. xy approach to 0, 0. We get 1, right? So constant, give us the constant. So look, if we have fixed y equal to 0, we get 0 for the limit. If we have x equal to y squared, the limit is equal to 1. So we can conclude that the limit does not exist, right? Okay, let's talk about the continuity at a equal to 0. Okay, so here is continuity at point. So earlier when I introduced you, it's a calculus 1, continuity at x equal to 8, right? In the case point AB, they indicate as xy, right? So it's a domain. So talk about the domain, right? Must be in the domain, right? So we have three conditions, same as calculus 1, exactly same concept. Only difference is we add y, right? So we had f of x. Now we have f of x y, right? In 3 dimension. Okay, so f of AB exists means the function defined and evaluate the function, right? Okay, then limit exists. All right, function defined and limit exists and not middle finger, and then their value must be same, right? So that's the third condition, right? So function defined, limit exists, then they are same, okay? All right, now we have example. Show that the function continuous at 5 and -3, okay? All right, then we have to show 3 things. Okay, let's do evaluate, right? So f of AB, which is 5 and -3. So number 1. Sure. Okay, so we have f of 5 -3 equal to 3 and 5 plus to -3 over x 5 plus y. Ooh. Plus 1 equal to, okay, what do you get? It's a 3? Good. All right. So function defined, not undefined. Yeah, think about that, not undefined. Okay, now second one, limit exists. We need to show that. Copy. Sure. Yeah. So we're using limit when x, y approach to 5 and -3. Using this one. Copy. Yeah. Equal to limit x, y approach to 5, -3. Yeah, it's the same. We get the +3, right? Okay. Look, the third one, limit exists, and the function is defined. Then their value is the same. There we go, right? So just to conclude, right? So we have f of 5, -3 equal to 3 equal to limit xy approach to 5 and -3 of f of xy. Yeah, they are same, right? So um, thus therefore continuity, right? Therefore is continuous. Let me denote continuous this way, right? CTS continuous at the point 5, -3, right? Okay. Okay, so let me talk about the function of 3 or more variables. So we have as a function notation f of x, right? Then this is 2-dimension, right? 2-dimension with one variable, right? Just x. And we just learned that f of x, y is a 3-dimension with two variables, right? Then we have f of x, y, z is 4-dimension with 3 variables. It's a function notation, right? F of x, y, z, t is a 5-dimension with 4 variables, right? You guys okay with this? Yeah. Okay. Now, when do we use four dimensions? So temperature at physical location. And when do we use 5 dimension air pressure and location, right? So don't get confused. The triple, this is a point, right? This is a function notation like that, right? So in real life, we are using 3 dimension, right? But then physics, linear algebra, other subject, we are using more variables, more dimensions, more than 3 dimensions, okay? All right, now let's find the limit. Find the limit of, we have, limit xyz approach to 4, 1, -3, x squared y minus 3z over 3x plus 5y minus z, okay? So if we have a quotient, then we check the denominator quickly. 1, 2, 3. What do you get? Good. 16. All right. So it's not 0. Then we can just apply, right? So let's apply limit x, y, z approach to 4, 1, -3. So we have, let me just using black, 4 squared y, which is 1 minus 3 times z over 3 times x, 4 plus 5 times y minus z. Can you please calculate? 25 over 16. Very good. Okay, now let's do this one. I'm gonna bring the note here. Okay, once again, calculus 1 stuff again. So we knew when x approaches when x approaches to 0, right? What is the limit of sine x over x? We knew that it's equal to 1, right? It's the same as x over sine x. Yeah. We showed you, first of all, by geometrically, we show that this one. Secondly, we show that by graph, or just make a table, right? And not middle finger. Thirdly, we show that by indefinite form. Then we are using L'Hopital rule, right? So we are using L'Hopital rule, then we get the 1, right? Okay, now what if we have sine 3x x, same limit when x approaches to 0? What do you get, right? We multiply by 1. What kind of 1 in the case? 3 over 3. Then this is 1 because of that. Same shape, right? Sine x over x. Sine 3x over 3x, same shape. So it's 1, then we get 3. Or same thing, L'Hopital rule, right? So we get derivative of sine 3x over x, we get cosine 3x times 3, right? General over 1. And then we have to have a limit. Then when x approaches to 0, what do we get? We get 3, right? Okay. Now, calculus 3. What is this? It's the same shape, right? Same shape as this. Then this is 1, isn't it? this is the same as limit xy approach to 0, 0, xy over sine xy, right? Same concept. Okay, let's do one more. Find limit xy approach to 7, 6, x minus y minus 1 over square root of x minus y minus 1, right? So it's a, oh, cannot see. It's a quotient. Then what did I say earlier? We check the denominator quickly. 1, 2, 3. What do you get? Okay, very good. 0, right? Okay, if we get 0, what about the numerator? It's also 0, right? Okay, we call this is indeterminate form. Then we have to do something else, right? Okay, so from the calculus 1, if we have radical, what kind of technique we are using it? Do you remember? Conjugate, right? So we are multiplying by conjugate, that technique, right? Multiplying by conjugate. Same technique, we're using it. So we have this. This is the last question, so hang in there. Conjugate. So conjugate means we have the same format except opposite side, right? So square root x minus y inside plus 1 over square root x minus y plus 1. Yeah, that's the conjugate. Only the sign different. Okay, then let's simplify. Why are we multiplying by conjugate? Because we want to get rid of that radical, right? So that will be limit x, y approach to 7, 6. The numerator, I'm sorry, denominator has x minus y minus 1, right? So note. You might forget. Note. A minus b, a plus b, which is a squared minus b squared, right? That's why the denominator is like that. Okay, then numerator. What do we have? X minus y minus 1, and then square root of x minus y plus 1, right? Okay, so when we using conjugate technique, please don't multiply together because we need to simplify. Means that we need to reduce, right? So there will be cancel out, right? Then we get x, y approach to 7, 6. So we have a square root of x minus y plus 1. That's it. Okay. No longer exists the quotient, right? Then we can apply the limit. So that will be so 7 minus 6 plus 1, which is 2. Yeah, very good. Okay, thank you for watching. I will see you next time. Bye.